What if you could run AI models faster than ever before, optimize deep learning pipelines for cloud and edge, and deploy real-time video, speech, and sensor AI, powered by the world's most advanced GPUs? You're not dreaming. You're stepping into the NVIDIA AI ecosystem. This course is your all-in-one launchpad to become a certified NVIDIA AI expert. Module 1, NVIDIA Hardware Ecosystem and GPU Compute Foundations. We begin by understanding the foundation. NVIDIA's powerful GPUs like A100, H100, L4, and Jetson. You'll learn how to spin up GPU-powered instances on AWS and Azure, and get hands-on with DGX and NVIDIA AI Enterprise. Module 2, NVIDIA AI Containers and NGC Registry. Discover how to tap into the NVIDIA NGC Registry to deploy AI containers, models, and toolkits with confidence. Learn how to configure drivers, manage licenses, and secure containerized AI workloads from cloud to edge. Module 3, Inference at Scale with Triton and Tao Toolkit. Build production-grade inference systems using NVIDIA Triton and optimize your models with Tao Toolkit, TensorRT, and ONNX. You'll accelerate inference speed while reducing compute costs without sacrificing accuracy. Module 4, Real-Time AI with DeepStream and Rapids. Enter the world of real-time AI. With DeepStream, you'll process live video, sensor feeds, and event data. Use Rapids to turbocharge your data pipelines with GPU-accelerated analytics for blazing fast performance. Module 5, Digital Twins and Omniverse Integration. Want to build digital replicas of real-world environments? Learn to use NVIDIA Omniverse to simulate physical spaces, stream in sensor data, and power AI-driven interactions, perfect for manufacturing, robotics, and smart cities. Module 6, Edge AI with Jetson and IoT Sensor Fusion. The edge is where AI meets the real world. Master Jetson Orin and Xavier, and deploy lightweight, optimized models that integrate live IoT sensor data. Build smart edge solutions for vision, robotics, or retail. Module 7, Model Ops and Lifecycle Management. Learn how to manage the complete machine learning lifecycle. Training, fine-tuning, versioning, quantizing, and deploying models. Build your own automated model ops pipeline using best-in-class NVIDIA tools. Module 8, Cloud-Native AI and DevOps for NVIDIA Stack. Deploy and manage GPU-accelerated AI workloads using Kubernetes, Helm, and cloud-native DevOps strategies. You'll learn how to scale securely, license enterprise models, and operate multi-node GPU clusters with confidence. Module 9, NVIDIA Vertical SDKs Overview. Explore NVIDIA's vertical platforms, like Metropolis for smart cities, Riva for conversational AI, Nemo for large language models, Clara for healthcare, and Merlin for recommender systems. Module 10, Capstone Project. Bring everything together in a final project where you'll build an end-to-end pipeline from cloud GPU deployment to edge inferencing, integrating real-time data, AI models, and NVIDIA's full software stack. Whether you're an AI engineer, ML ops specialist, or edge computing architect, this course gives you the tools, knowledge, and hands-on skills to join the elite ranks of NVIDIA AI experts. The future of accelerated AI is here, and it starts with you. Start now and take your GPU-powered AI skills to the next level. In this lesson, we'll explore the core of NVIDIA's AI acceleration engine, its GPU architecture. From the powerful A100 and H100 designed for hyperscale AI training to the compact Jetson modules that power edge AI in drones, robots, and IoT devices, NVIDIA offers a specialized GPU for every workload. You'll learn how each GPU differs in architecture, use case, and performance profile, and how to choose the right one for your AI deployment. Whether you're working in the cloud, the data center, or the edge, let's dive into the silicon that powers the future of AI. NVIDIA's GPU lineup isn't one size fits all. It's a targeted ecosystem. The A100 and H100 are data center class GPUs, purpose-built for large-scale AI training and inference tasks. These are the workhorses behind LLMs, computer vision, and HPC workloads. Then you have the L4 GPU, a more efficient, low-power option optimized for real-time inference, ideal for video analytics or speech AI. Finally, the Jetson series powers Edge AI. These tiny but powerful devices go into smart cameras, autonomous robots, and embedded systems. Across all these GPUs, performance comes from CUDA cores for parallel computation, tensor cores for deep learning acceleration, and high memory bandwidth to move data fast. The A100 GPU is based on NVIDIA's Ampere architecture and delivers massive parallel performance. It features third-generation tensor cores, which are tuned for mixed precision and optimized deep learning performance. One standout feature is multi-instance GPU, or MIG, which allows you to partition a single A100 into multiple isolated instances, ideal for shared cloud deployments. With up to 80 gigabytes of high bandwidth memory, the A100 is perfect for large-scale workloads. Think LLM training, advanced computer vision, and even simulations in healthcare or finance. It's the go-to GPU for full-scale AI infrastructure. The H100 is NVIDIA's most powerful GPU to date, built on the Hopper architecture. What sets the H100 apart is the Transformer engine, optimized specifically for transformer-based AI models like GPT, BERT, and Stable Diffusion. It features 4th-gen tensor cores and advanced FP8 support, enabling faster training and inference with less memory footprint. The H100 supports NVLink and NVSwitch, allowing GPUs to work together with lightning-fast interconnects, crucial for model parallelism. It's designed for hyperscale generative AI and will be the backbone of next-gen AI infrastructure. If the A100 and H100 are AI powerhouses, the L4 is your lean, production-ready engine. It's designed for real-time inference, perfect for applications like video analytics, recommendation engines, and conversational AI. With a single slot, low power profile, it's easily deployable in dense server environments. This makes it ideal for inference at scale scenarios like search ranking, chatbots, and RAG pipelines. If you're building AI services that need speed, efficiency, and scalability, L4 is your best friend. The Jetson series brings AI to the edge. These are tiny yet mighty modules, like the Jetson Orin, Xavier, and Nano, built for real-time compute on low power. Whether it's running object detection on a drone, facial recognition on a kiosk, or robotic vision in a factory, Jetson modules deliver GPU-class performance in compact devices. They support the full NVIDIA stack, TensorRT, CUDA, DeepStream, and make it possible to deploy AI where latency matters and connectivity may be limited. With Jetson, you're not just building AI, you're embedding intelligence into the physical world. NVIDIA's GPU lineup is not just hardware. It's a performance spectrum built for every AI need. Whether you're training massive models on the H100, deploying fast inference with L4, or running real-time analytics on Jetson at the edge, knowing your GPU architecture is key to building efficient, scalable AI systems. Next up, we'll explore how to launch GPU instances on AWS and Azure and get your NVIDIA-powered AI infrastructure up and running in the cloud. Once you understand NVIDIA's GPU architecture, the next step is launching these GPUs in the cloud. In this lesson, we'll cover how NVIDIA GPUs are offered as cloud instances on AWS and Azure. You'll learn about instance types like P4D, G5, NC, and ND, what workloads they're designed for, and how to provision GPU-powered virtual machines for AI workloads. By the end, you'll be ready to spin up your own cloud-based GPU lab for training, inference, and experimentation. Running GPUs in the cloud gives you flexibility, power, and cost control. You don't need to buy hardware or worry about managing a data center. You can simply rent GPU capacity when needed. Cloud GPUs allow you to scale quickly, whether you're training a large language model or running real-time inference for a production app. With container-based deployments and shared images, you also get reproducibility, ensuring your development and production environments stay in sync. On AWS, NVIDIA GPUs are offered under several instance families. The P4D and P5 instances use A100 and H100 GPUs respectively, perfect for compute-heavy training and multi-GPU workloads. G5 instances come with L4 GPUs, optimized for inference, video processing, and high-performance graphics tasks. Be careful not to confuse these with Infi2 instances, which are built on AWS Inference chips, not compatible with NVIDIA software. AWS offers deep learning AMIs preloaded with drivers and frameworks, or you can bring your own containerized environment via the NGC registry. On Microsoft Azure, NVIDIA GPUs are accessible through the NC, ND, and NV families. The NC series is suited for general-purpose GPU compute, great for smaller AI models and experimentation. The ND series supports V100 and A100 GPUs and is built specifically for deep learning. The NV series is mainly for GPU-accelerated visualization, so it's not recommended for AI workloads. Azure also integrates with Azure Machine Learning, AKS, Kubernetes, and Batch AI, all of which support NGC containers and NVIDIA accelerated workloads. Choosing the right GPU instance depends on what you're building. For large model training or fine-tuning, go with A100 or H100 instances like P4D or P5 on AWS or ND series on Azure. For real-time inference or lightweight pipelines, L4 GPUs on G5 instances are ideal. Remember, Jetson devices are for edge use only. You won't find them in the cloud. Always factor in not just GPU, but also CPU, RAM, networking, and cost. And make sure the instance supports the right driver and CUDA version for your tools. Ready to get hands-on? On AWS, choose a G5 or P4D instance and launch it with the Deep Learning AMI to get pre-installed drivers and frameworks. On Azure, launch an ND series instance with Ubuntu, then install the necessary NVIDIA drivers manually. Use SSH or a browser-based IDE like JupyterLab to access your instance. Run NVIDIA SMI to confirm the GPU is active, and install Docker so you can start running model containers from the NGC registry. This is your first step toward full-stack AI acceleration. Cloud GPUs give you access to world-class AI compute on demand. Whether you choose AWS or Azure, knowing which instance type supports which GPU will help you match compute to workload. In the next lesson, we'll explore DGX Systems, NVIDIA's purpose-built hardware for enterprise AI, and how DGX Cloud can take your model training to the next level. When your AI ambitions go beyond what a single GPU instance can handle, you step into NVIDIA DGX territory. DGX Systems are purpose-built AI supercomputers, integrating the fastest GPUs, high-speed networking, and massive memory bandwidth to train the most demanding AI models. And with DGX Cloud, NVIDIA has made this power accessible on demand, without the need to own the hardware. In this lesson, you'll learn how DGX systems are designed, what they excel at, and how DGX Cloud can turbocharge your AI projects. NVIDIA DGX systems are not just servers with GPUs. They are engineered AI supercomputers. They integrate multiple A100 or H100 GPUs connected with NVLink and NVSwitch, enabling GPUs to share data at extreme speeds without bottlenecks. The design includes optimized cooling, power delivery, and software pre-configured for AI workloads. This makes DGX the gold standard for training large-scale deep learning models, especially when distributed across multiple GPUs. There are two primary DGX models in production today, DGX H100 and DGX A100. The DGX H100 packs 8 Hopper H100 GPUs with the Transformer engine, designed to train the largest generative AI models at record speed. The DGX A100 uses 8 Ampere A100 GPUs with multi-instance GPU support for workload partitioning. Both come with NVIDIA AI Enterprise pre-installed and support multi-node scaling through InfiniBand networking. These systems are deployed by enterprises, research institutions, and hyperscale AI labs around the world. Every DGX system ships with the NVIDIA AI Enterprise software stack. This includes pre-optimized builds of TensorFlow, PyTorch, and Rapids, as well as NVIDIA's inference and optimization tools like Triton Inference Server and TensorRT. It's fully container ready, so you can pull workloads directly from the NGC registry and run them without complex setup. DGX systems are also multi-user capable, meaning multiple teams can share resources securely. DGX Cloud brings the power of DGX systems to the cloud. Instead of buying and hosting the hardware yourself, you can access H100 or A100 DGX class compute directly from your preferred cloud provider, whether it's Azure, AWS, Google Cloud, or Oracle Cloud. Each DGX Cloud instance comes preloaded with the NVIDIA AI Enterprise stack, so you can start training large models immediately. It's the perfect solution for organizations that need top-tier performance without the capital expense. The choice between DGX hardware and DGX cloud comes down to workload patterns and investment strategy. If you're running AI workloads continuously and have the budget, owning DGX hardware ensures predictable, always-on performance. If you have bursty or project-based workloads, DGX Cloud gives you the same performance without the upfront purchase, paying only for what you use. In both cases, you get NVIDIA's enterprise-grade hardware, software, and support. DGX systems are the Formula One cars of the AI world, blazing fast, precision-engineered, and built for peak performance. And with DGX Cloud, NVIDIA has made this power accessible to any team, anywhere, without the cost or complexity of owning the hardware. In the next lesson, we'll get hands-on with NVIDIA AI Enterprise, installing drivers, configuring operators, and setting up our first containerized AI workload. NVIDIA AI Enterprise is the backbone of the NVIDIA software ecosystem, providing a fully tested, secure, and optimized environment for running AI workloads on NVIDIA GPUs. In this lesson, you'll learn what's inside NVIDIA AI Enterprise, why drivers and operators are critical, and how to set up your environment for both on-premises and cloud deployments. By the end, you'll have the knowledge to get your NVIDIA GPU infrastructure ready for production AI workloads. NVIDIA AI Enterprise is an end-to-end AI software platform designed for enterprises that need reliability, security, and performance. It comes pre-tested and certified for NVIDIA GPUs, meaning no guessing whether a specific driver or library version will work. The suite includes optimized builds of popular AI frameworks like TensorFlow, PyTorch, Rapids, as well as NVIDIA's own tools for deployment and optimization. It's licensed and backed by NVIDIA support, making it suitable for mission-critical AI systems in production. NVIDIA AI Enterprise includes everything you need to run AI at scale. At the foundation, you have GPU drivers and the CUDA toolkit, enabling GPU acceleration. The NVIDIA Container Runtime allows containers to directly access GPU resources. On top of that, you get Triton Inference Server for scalable deployment, TensorRT for model optimization, and full access to NGC, NVIDIA's curated container registry. These components are pre-integrated, so you spend less time troubleshooting and more time building. Installing the correct NVIDIA GPU driver is the first step in setting up your AI environment. The driver must match your CUDA toolkit and AI framework versions. Otherwise, you'll run into compatibility issues. On Ubuntu, you can install drivers via apt repositories or NVIDIA's .run installer file. On Windows, use the NVIDIA driver downloads page. If you're on AWS or Azure with a deep learning AMI, the driver is often pre-installed. Just confirm it's working by running NVIDIA-SMI in your terminal. If you're running GPU workloads in Kubernetes, you'll need NVIDIA operators. The GPU operator automates driver installation, configures the container runtime, and enables GPU monitoring inside the cluster. The network operator configures high-performance GPU networking like InfiniBand or Roki, critical for multi-GPU and multi-node training. You can deploy these operators using Helm charts or from Operator Hub. Once installed, they ensure your Kubernetes nodes stay GPU ready even through upgrades. Once your drivers and operators are in place, you can start running AI workloads inside containers. First, install Docker and the NVIDIA Container Toolkit, which allows containers to use GPUs. Then, Pull AI containers directly from the NGC registry. You'll find PyTorch, TensorFlow, Rapids, and even ready-to-use inference servers. When launching containers, use the -GPUs all flag to grant GPU access. From here, you can integrate your container workflows into CI/CD pipelines or full ModelOps automation. Let's preview our hands-on setup. First, launch a GPU instance, like an AWS G5 or Azure ND series. Install the correct NVIDIA driver and verify with NVIDIA SMI. If you're using Kubernetes, install the GPU operator to automate GPU readiness. Install Docker and the NVIDIA Container Toolkit, then pull a PyTorch container from NGC. This process will give you a fully operational NVIDIA AI Enterprise environment, ready for development and deployment. NVIDIA AI Enterprise takes the complexity out of running AI workloads on GPUs, giving you a secure, optimized, and supported software stack from the driver layer all the way to inference deployment. In the next lesson, we'll put all this into practice in a hands-on lab, setting up a GPU-powered VM on AWS with NVIDIA drivers and running our first containerized AI model.